going to be organic chemistry. And as usual, you can see we have a list of vocabulary terms, actually a very lengthy list here related to the organic chemistry unit. Once again, I highly suggest that you make up some note cards related to these terms and spend roughly 5 minutes a night just quizzing yourself based on these vocabulary terms for organic chemistry. Also listed are unit objectives. I'm not necessarily going to go through each and every single one of them with you, but do take a look at the list to see some of the topics of discussion that we will have for this Unit 11 on organic chemistry. Now, on to page number 3, let's do a brief introduction for our first podcast related to organic chemistry. What organic chemistry is, and it really just kind of pertains to 2 different elements. And that's it. Organic chemistry is the study of compounds that contain the 2 elements carbon and hydrogen. All of the other elements on the periodic table really don't come into play until later on in this unit when we start talking about different types of organic compounds that could be present. For example, halides, alcohols, ethers, esters, amines, ketones, right? Then we'll start to incorporate some other elements. But at this point right now, we are only concerned with carbon and hydrogen as far as organic chemistry goes. For example, if we had a compound of carbon dioxide, this is not organic. This would be classified as inorganic. Okay, just to kind of give you an example. So it has to involve both carbon and hydrogen. All right, now, why is it that carbon is considered to be so special? Well, carbon, as we know already, has 4 valence electrons. All right, and with the 4 valence electrons, we can certainly see that there are 4 different sites for chemical bonds to be formed, typically going to be covalent bonds. Carbon is also considered to be the backbone of the organic chemistry unit we're getting into. Now, speaking of these 4 single bonds that can be set up within a carbon atom, what happens is when these 4 bonds are formed, they spread out evenly. So if this is our carbon atom here, and these are our 4 hydrogens attached to this one carbon atom, like you would have up here. This particular example right here is a non-bonding version. This is the one we're going to incorporate more so than this one. But as you can see, the 4 single bonds are spread out as much as possible. What they form is what is called this should be a review term as well, tetrahedral molecule. Kind of looks like a tripod. So 3-dimensionally, what's going to happen, you can see it's a little bit easier to see, is that you're going to develop degrees of angle of 109.5 degrees between each hydrogen atom that's attached to the carbon atom. And the reason they're going to be spread out to the max is because with the hydrogen atom, you're dealing with positive charges, so they're going to push each other away. They're like charges, and they're going to repel against one another. Here's a 2-dimensional look at it. You can see you've got your carbon atom, and here's your 4 hydrogens as well. It is the same setup as the 3-dimensional, however, it's obviously 2-dimensional because you're drawing it on a piece of paper. Now, these carbon atoms that are involved with organic chemistry, they are going to share electrons, and that should make sense because we're dealing with covalent bonds here, and we know that covalent deals with the sharing of electrons. So the carbon atoms are going to share their electrons with other carbon atoms, and they will form covalent chains, and in some cases they will form covalent rings as well, and they'll make networks, like diamonds, if you will. Right. Some of these carbon chains, rings, networks that you're going to see, they're going to be huge. They're going to be massive in size. You might be talking about a carbon chain that could go up to 500 carbon chains that are aligned with one another. Right. So you're talking about some very, very large chains that could be present. Now, two adjacent carbon atoms, what they will do is they're going to share up to 3 pairs of electrons. What's going to happen is a triple bond will be formed here. Right. Sorry, that's my analogy here. Triple bond will be formed. Each shared pair of electrons is represented by a dashed line, which of course we know this represents a single bond. Okay. We'll also see double bonds as well. Now let's talk specifically about what is called these hydrocarbons. Right. These are your organic molecules. They only contain the 2 elements, like we talked about, carbon and hydrogen. Now there's, as you're going to see, there are 2 different types of hydrocarbons. The first type of hydrocarbon is called a saturated hydrocarbon, and the second one is called an unsaturated hydrocarbon. All right, saturated first. This is where all hydrocarbons, they're all single bonds. No doubles, no triples. They're all single bonds between the carbons. The maximum number of hydrogens attached, right? It's the same way a saturated solution, right? We talked about solutions earlier this year. Now they're saturated. Holds the maximum amount of a solute. When we're dealing with saturated hydrocarbons, it's very similar. It holds a maximum number of hydrogens. So there is a relationship between the maximum number of hydrogens in organic chemistry and the maximum number of ions that are held within a saturated solution. Very similar to one another. Single dashed line for all saturated hydrocarbons would look something like this. Like we said, they're all going to be single bonds, no doubles, no triples. So what you're going to have is one shared pair of electrons, which is going to mean a total of 2 electrons present to make up all of the bonds. Right? There's 2 electrons that are being shared. Here's an example down below. As you can see, we have 1, 2, 3 carbons. Each carbon has 1, 2, 3, 4 different sites for carbon chain to continue. But as you can see, they are sharing, whether it's a bond between the carbon and the other carbon atom or a carbon and a hydrogen atom, you can see that they're sharing a pair of electrons for a total of 2 electrons altogether. So all saturated bonds are all single bonds. Unsaturated hydrocarbons, you're going to have at least 1 multiple bond. Right, you're going to have at least 1 double or 1 triple bond within the carbon chain. There are 2 dashed lines in some cases. It looks something like that. That is going to be called a double bond. So in essence, what's happening here is you have 2 shared pairs of electrons, which is going to be a total of 4 electrons. It's going to be made up with, like we said, a double bond. So it look like this, or like we mentioned at the beginning, number 1 could look like this. Now, an example that's listed down below, as you can see, here is our minimum of 1 multiple bond. In this case, it's going to be a double bond. And then from there on out, you can see that there's a single bond here, 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 and here. But what makes this an unsaturated hydrocarbon is because of at least that 1 multiple bond, and in this case, it is our double bond. Now, on to the next page, number 4, we're going to take a look at just at the top here. 3 dashed lines. 3 dashed lines, obviously, is going to be a triple bond. Throw that again. All right, here is our triple bond of carbon. And what a triple bond is, it is 3 shared pairs of electrons. And in essence, what you have is you have a total of 6 electrons present. And like we said, it's going to develop a triple bond. Could also look like this. One example that's provided for us, as you can see, here's the 1 triple bond right there. And everything else is going to be a single bond between the carbon and the hydrogens, multiple locations. Okay, so when you're dealing with 3 dashed lines, you're dealing with triple bonds. This is the second example of what an unsaturated hydrocarbon